Hello guys, good afternoon, good evening. Yeah, hi. ನಮಸ್ಕಾರ. ಇದೀರಾ ಇಲ್ಲಿ?
ಹೌದು ಸರ್.
ನೈಸ್. ಮತ್ತೆ ವಿಶೇಷ ಹೆಂಗಿದೆ, ಏನು ನಡೀತಿದೆ? ನಿಮ್ಮ ಮಿಡ್ ಟರ್ಮ್ ಏನೋ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ಅಂದರು, ಏನು ಕತೆ?
ನೆಕ್ಸ್ಟ್ ಮಂತ್ 5 ಸರ್.
ನೆಕ್ಸ್ಟ್ ಮಂತ್ ಯಾವಾಗಿಂದ?
5th.
ಸೊ ಫಿಸಿಕ್ಸ್ ಯಾವಾಗ ನಿಮಗೆ? ಹಲೋ, ಯಾರು ಮಾತಾಡ್ತಿದ್ರಿ? ಅವರು ಫಿಸಿಕ್ಸ್ ಯಾವಾಗ ನಿಮಗೆ? Nice. Yes guys, good evening everyone, good evening. So we'll start class exactly by sharply by 5 p.m. okay? Right, 5 p.m. More 2 minutes to go. ಓಕೆ, ಎಲ್ಲ ರೆಡಿನಾ? ಓದ್ಕೊಂಬಂದ್ರ? ನಾನು ನಿನ್ನೆ ನಿಮ್ಗೆ ಓದ್ಕೊಂಬರಕ್ಕೆ ಹೇಳಿದೆ. So I had asked you guys to come prepared to class. I hope all of you have done preparation. Okay, good evening. Hi Prakash, heli. Okay, now let's begin the class with a quick technical check. So yeah, no, 15th physics. Okay, cool, chill. 15th andre chill. So I think you guys might be having 2 days of holiday for physics, as I got to know. 2 ದಿನ ಫ್ರೀ ಇದೆ ಅಂತ ಕೇಳ್ಪಟ್ಟೆ, ನಿಜಾನ ಗೊತ್ತಿಲ್ವಾ. ಬಟ್ ನೋಡಿ, ಫ್ರೀ ಇದ್ದರೆ ಹೇಳಿ ನನಗೆ ಒಂದು ಮಾತು, ಚೆನ್ನಾಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಮತ್ತೆ ಎಸ್ we'll be starting soon, exactly by 5. So one thing is, we'll try to keep our conversation, most of it in English. ಸಪೋಸ್ ಯಾರಿಗಾದ್ರು ಏನಾದ್ರು ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ಅಂದರೆ ಅವಾಗ ಮಾತ್ರ ಸ್ವಲ್ಪ ಕನ್ನಡ ಯೂಸ್ ಮಾಡೋಣ. ಅಂದರೆ ಏನು, ಇದು ದಿಸ್ ಕ್ಲಾಸ್ ಇಸ್ ಬೀಂಗ್ ರೆಕಾರ್ಡೆಡ್, ರೈಟ್? So we'll just keep it in English. Yes, you will get the recordings. Don't worry, you will get the recordings. Shweta, hi. Yes, so one thing guys, very important thing is, good evening. So one very important thing is, everyone should participate actively. Everyone must participate actively in the class. So ಯಾವತ್ತೇ ಏನೇ ಕ್ವಶನ್ ಕೇಳಿದ್ರು ಟಕ್ಕಂತ ಆನ್ಸರ್ ಮಾಡೋದು ನಮ್ಗೆ ಖುಷಿ ಆಗುತ್ತಪ್ಪ ಮಾಡೋದಕ್ಕೆ, ಅಲ್ವಾ? ಸೊ ಮೋರ್ ಯು ಗಿವ್, ದ ಮೋರ್ ಯು ಗೆಟ್. ಅಲ್ವಾ? ಸೊ ನಿನ್ನೆ ಒಂದು ಪ್ರಾಮಿಸ್ ಮಾಡಿದ್ರಿ ಎಲ್ಲರೂ. ಐ ಹೋಪ್ ಯು ರಿಮೆಂಬರ್ ಯುವರ್ ಪ್ರಾಮಿಸ್ ಯೆಸ್ಟರ್ಡೇ. ಎವ್ರಿವನ್ ಗೇವ್ ಮಿ ಅ ಪ್ರಾಮಿಸ್. ವಾಟ್ ವಾಸ್ ದಟ್? ಯಸ್, ಶಬಾಷ್. So you should remember that. So what? You should help your friends, you should help yourself. If you have any doubts, you should ask. If I'm doing anything wrong, you should notify me. If you are doing anything wrong, I'll notify you. It should be there. So yes, and one more thing was, everyone said you will be studying daily in your homes. Manali ಓದ್ತೀವಿ ಅಂತ ಅಂದಿದ್ರಿ daily. And one more thing was, you promised to also listen carefully and be alert. Always active in class. So there were hardly 45 students yesterday in class, but I'm expecting more. As I got the number was very, very huge. So hope everyone knows my meeting code and the password. So if you don't know, or if someone don't know, please help them join the class, right? So I see most of you are from JNV Udupi and JNV Bangalore. Why is JNV Bangalore? Ambika? So I see one student from Gen Bangalore. Okay, and that's not actually that's not supposed to be supposed to happen. You guys are so everyone from Gen Bangalore are supposed to join maths class or biology class as per the timetable. You are still in physics class. I don't know if you are here by mistake, and if you are from Bangalore, if you are from here by mistake, you could shift because your physics class is done, right? Yeah. Yes, guys, come on. So I see hardly 23 students have answered for out of 27 students. Okay, you are from Ballari. Cool, 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 cool. Okay, okay, cool, nice, cool, guys. So yeah, hope you guys came prepared to the class. Just we'll start the class now. So there are hardly yep, it's 5 plus. Okay, guys. So everyone is able to hear me, and my screen is visible. So yep, in today's class we'll be starting with an, an example. So we'll start with the example. Okay, cool. So what do you see here? Oh, what's happening? So we see four situations here. So there is a boy who is rubbing balloon on his hair, and he sees what he sees. Okay, he sees that the balloon is his hairs are being attracted to the balloon. Wow. Then there is another man who is using a comb and is rubbing the comb with a cloth. Now, okay, he's rubbing the comb with the cloth. Yes, then he's keeping the cloth. I mean the comb. I mean he's bringing the cloth or sorry, he's bringing the comb near the paper pieces. Now these paper pieces are being attracted. Wow. Then okay, third another image shows there is a lightning. Okay, there is a lightning, and I see okay, yep, and there is a flash of lightning. Wow, superb. So and in one of the image, the starting image, so you see a faucet where water is being poured continuously, and when we rub a balloon and we bring that balloon near the faucet, what happens? The water is being bent. Water nodi near nodi bend ಆಗ್ತಿದೆ. So why are all this happening? Guys, take some time and think. So a person's hair is being attracted to balloon, the paper attracted to the comb, lightning, bending of water. What are happening here? What is happening here, guys? Exactly. ಏನಾಗ್ತಿದೆ ಇಲ್ಲಿ? Answer in the chat. So what's exactly happening here? What's happening there? Okay. So yes, in lightning there is an electric discharge, and I want everyone to answer. Guys, are you able to hear me? Yes. Yeah. So cool. So I see one of the transfer of electrons. Cool. Then. Yes. Traction. Again. Need more answers. More answers. Come on, guys. Okay. Why does that happen? So most of you are telling, sir, body is getting charged by some means, right? Sir, body charge ಆಗ್ತಿದೆ. ಯಾಕೆ ಆಗ್ತಿದೆ? ಹೆಂಗಾಗುತ್ತೆ? Yes, body is getting charged, so these are happening. Okay, right. Okay, let's check each and every case. Now, what did you learn after testing? When you rub a balloon on your hair, what happens to hair? What happens to your hair and what happens to the balloon? Okay, when you rub your balloon on your hair loses some electrons. So whatever the electrons present in your hair is being lost to to the balloon, and what happens is the hair gets positively charged. I have represented that here. The hair gets positively charged and the balloon gets negatively charged. Next, the balloon gains negative charge. Yes? Yes. Okay. Now what happens? So since one is having positive charge and the other is having negative charge, it attracts. So why does this happen? We'll study in today's class. Okay. Next thing, what happens to the comb? The comb is being rubbed on the cloth. What happens to the comb? Right? What happens to the comb? And when it's brought near to the paper piece, why does paper piece attract? Tell me. Yes, Sri Raksha. Yes. So on rubbing the comb with cloth, what would happen? Guys, reply. Reply in chat box. What is happening? Yes. Yes. Come on, guys. Come on. Yes, there is some electrostatic force taking place. Okay, there is some charge being acquired. Yes. Loss of electron is happening. Excuse me. Charge is being released. Yeah. Again. Yes, yes. Again, guys, come on. What else? What else? So when the paper pieces are being present here, what happens when we rub our comb with the cloth? When we rub our comb with the cloth, so what's happening? The cloth loses its electron. Whatever the cloth loses electrons. To whom? It loses electrons to the comb, and the comb, all the electrons is being gained by the comb, and it gets negative charge. Now, what charge will the cloth get? What charge will the cloth get? The cloth is losing electrons. What charge will the cloth get? Tell me. Yes, the cloth gets positively charged. Now, guys, yes. Okay, sir, fine. The comb gets negatively charged. There is some electrons, so the comb got negatively charged. Fine. Cloth got positively charged. It's also fine. Now, what happens when it's brought near the paper? Why does paper attract? We didn't charge the paper, right? We didn't charge the paper, did we? No. So we didn't charge the paper. So since we did not charge the paper, but yet my paper is being attracted. Why do you think the paper is attracted? Want to know? So if you want to know, stay tuned to the class. Okay. So I can give you a quick answer. The quick answer is the charged comb induces opposite charge on paper and it attracts. So paper will get a positive charge. But did you understand anything? Maybe. But wait, we'll learn more about it in upcoming slides. Okay. Next. Okay, what's here? We have the lightning. So there is a lightning. So what's happening in the lightning? When lightning occurs, what's happening? What's happening? The clouds which are rubbing each other, the clouds are rubbing to each other, and what's happening? Due to friction, the charge is being transferred. I mean, the clouds, okay, the clouds will store n number, most of the charge. The clouds will store most of the charge, and it will discharge. After storing most of the charge, the clouds, the negative charges on the clouds which are stored for long time. Okay, on rubbing, what happens? The clouds on rubbing. So what happens? ಒಂದಕ್ಕೊಂದು ಮೋಡ ಡಿಕ್ಕಿ ಹೊಡೆಯುತ್ತೆ ನೋಡಿ, ಆಕಾಶದಲ್ಲಿರುವಾಗ ಮೋಡ ಒಂದಕ್ಕೊಂದು ಡಿಕ್ಕಿ ಹೊಡೆಯುತ್ತೆ, ರಬ್ ಆಗುತ್ತೆ. ಆ ಸಂದರ್ಭದಲ್ಲಿ, ಆ ಟೈಮ್ನಲ್ಲಿ ಏನಾಗ್ತಿರುತ್ತೆ? ಚಾರ್ಜ್ ಒಂದು ಕ್ಲೌಡ್ ಇಂದ ಇನ್ನೊಂದು ಕ್ಲೌಡ್ಗೆ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಯಾವ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಿರುತ್ತೆ? ದೇರ್ ವಿಲ್ ಬಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ವಿಚ್ ಆರ್ ಫಾರ್ಮ್ಡ್ ಆನ್ ದ ಕ್ಲೌಡ್. ಸೊ ದೇರ್ ವಿಲ್ ಬಿ ನೆಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಒನ್ ಸೈಡ್ and there will be net negative charges on the cloud. So what's happening? Say if I have a cloud and if I have another cloud, so when these two clouds collide or rub, what happens? One cloud gains a positive charge, net positive charge on one side, other cloud gains a net negative charge on this other side. Now, okay, yes. So charge which has, okay, say this cloud gains most of the negative charge. Okay, now this cloud should discharge somewhere. What happens? All the negative charges, after it gains lots of it, ತುಂಬಾ 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 ಜಾಸ್ತಿ ಇನ್ನೇನು ತಡ್ಕೊಳಕ್ಕಾಗಲ್ಲ, ಆ ಟೈಮ್ನಲ್ಲಿ ಏನು ಮಾಡುತ್ತೆ? ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ದಿಸ್ ಕ್ಲೌಡ್ ವಿಲ್ ಸ್ಟ್ರೈಕ್ ಎ ಥಂಡರ್ಬೋಲ್ಟ್ ಟು ದ ಗ್ರೌಂಡ್. Okay, if this is ground, this cloud will strike a thunderbolt to the ground. But okay, sir, if this cloud is striking a thunderbolt to the ground, what happens to the positive charges? Okay, guys, so all the positive charges also is being released, but it will go in upward direction. Okay, this is an extra information. ಸೊ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಇಂದ ಕೂಡ ಥಂಡರ್ ಬರುತ್ತೆ, ಆದರೆ ಅದೆಲ್ಲ ಮೇಲ್ಗಡೆ ಹೋಗುತ್ತೆ. ಇಫ್ ಯು ಸಿ ಎನಿ ಲೈಟ್ನಿಂಗ್ ವಿಚ್ ಇಸ್ going upwards from down to up, that's a positive charge. If you see any thunder line, I mean thunderburst which is happening downwards, it's all negative charges ಆ ಥರ ಅನ್ಕೋಬೋದು ಆಯ್ತಾ. So yes, the negative charges after accumulating in large numbers hit the ground. Okay, this is an example of electrostatics. Then what happens in the last case? Last case, when we bring a charged balloon near a faucet. So this is a water running faucet. This is a faucet which has continuous flow of water. Now when we bring this charged balloon near the faucet, what happens? The balloon which is charged, which is negatively charged, attracts the water towards itself. Why? We'll learn. There is something called as induction. So we'll learn about that. There is something called as induction which happens here. This balloon attracts the faucet's water. Okay, now what do you see common in all these four cases, guys? Tell me, do you see something common? Is there something common? What is common? Okay, somebody says rubbing of two substances, sir. Sir, there is rubbing happening. Okay, yes, in this case it's rubbing, in this case it's rubbing, also in this case it's rubbing. Yep. So there is lightning also, there is no rubbing happen. Okay, even in this case, yes, clouds are rubbing. Okay, one common thing. Second common thing, guys. Okay, one body is attracting the other. Yes, see, the balloon is attracting the hair here, the comb is attracting the paper here, the lightning is being attracted by ground here, and also water is being attracted by the balloon here. Yes, attraction is common. Then so there is rubbing action happening and there is attraction action happening. Then what else? So one more common thing, guys, come on. One more common thing. So in all these cases, yes, transfer of charge is happening. Charge transfer is happening. Okay, one more. So in all these cases, one thing is common. You would see that all charges are at one time stationary. Why? All charges, see, in this case balloon had some stationary charges, even in this case the balloon had some stationary charges, in this case the comb had some stationary charges, and here in lightning the clouds had some stationary charges. So one common thing is all these had a stationary charge, some stationary charge. The charges which were unable to move all had that, right? Correct. Now why did we study all this? What is this? We are going to study about electrostatics. What is electrostatics, guys? Electrostatics means, say, the word electrostatics is broken into two things. One do yaudu electro, one electro, which means electrons or charges. Electro here refers to charges. Next, the second word, statics. The word statics refers to rest. ಎಲೆಕ್ಟ್ರೋ ಅಂದ್ರೇನು? ಚಾರ್ಜಸ್ಸು. ಸ್ಟ್ಯಾಟಿಕ್ಸ್ ಅಂದರೆ ರೆಸ್ಟ್. ಎರಡು ಒಟ್ಟಿಗೆ ಸೇರಿಸಿದ್ರೆ ಏನಾಗುತ್ತೆ? ವಾಟ್ ಡು ವಿ ಗೆಟ್ ಟುಗೆದರ್? Get the study of charges which are at rest is called as electrostatics. What is electrostatics? Electrostatics is the branch of physics where we study about the charges which are at rest. ಆಯ್ತಾ? So these charges which are at rest are being studied. Okay, guys. Next thing which we okay, what are the contents which we are going to study in this chapter? Okay, Prem Kumar CK, hope you are you are in a possible network. Okay, you are not yet connected. Prem Kumar CK, please contact your classmates from your school so that you could get connected. So okay, network is good, cool. Okay, so yeah, now Prem Kumar, I'll give you a quick steps what to do. In your left bottom there is a earphone symbol. so that you can click on that. You will get join audio. I mean, you can join the audio there. Once you click there, you get, okay, I can't, shit, you can't hear, right? So to Prem Kumar, sorry guys, I need to help him. So Prem Kumar CK, please click on join audio. First click on join audio, then click on call over internet. So whoever have not connected, please do this. Yes, I hope all of you have connected now. Yes. Yep. Thank you. Thank you for your time, guys, and sorry for that. I guess yesterday you guys were not present for the Zoom training, so I'll make sure that from next class onwards I'll use training until you get familiarized. Okay. Yeah. So what are the contents we are going to study in this class today? So in this class today we will be studying about charges. Okay. What are charges? What are they? What are the properties? And okay, once we study about the properties, we also study about what, excuse me for this. So there is some trouble with my, yeah, I think this should work. So I will be studying about charges. In charges, what are we going to study about what charge, how a charge exists, how charge exists. Then we'll study about properties of charge. Okay. Then we'll study about what are different things which we are going to study. Okay. Then we'll study about how modes of charge transfer is going to happen. Okay. Next, we'll study about electric force, electric field, electric potential, electric dipole, and Gauss law in upcoming classes. In today's class, we'll study about charges. Okay. So let's start. Okay. Let's build an atom. Now, guys, how can I build an atom? Yeah, it's not possible, but how can I build an atom still? Yet, if it was possible, how could I build an atom? How could I build an atom? If it was possible, how can I build an atom? Tell me. So yeah, I have an atom here. So how can I build this atom? Yes, I can build an atom using neutron, proton, and electron. Okay. Okay, guys. So yeah, thanks, Moksha. Cool. It's correct. So to build an atom, I should need a proton. Okay, I have some set of protons. I have some protons. I have some neutrons, and also I have some electrons. I have some orbitals. Okay. Now what I'll do, I'll give a proton. Okay, I added a proton. Added a neutron. Okay, I'll add another neutron. Cool. Okay. Now, okay. See, I can see that neutrons are in excess, so I'm removing. Okay, so there should be equal number of protons, neutrons, and is there equal number of electrons? Okay, I have some electrons also. I'll add them. Okay, I'll add one more proton and one more neutron. Okay, so I added few protons, few neutrons, and few electrons, right? So this forms my atom. Correct. Done. Now, what can you say about protons? What can you say about protons? What can you say about protons, guys? Yeah. So we can say that, yeah, protons are positively charged particles. So we have our neutral atom here. So we have literally protons are positively charged particles. Neutrons have no charge. Okay, neutrons doesn't have any charge. What about electrons? Electrons are negatively charged. Okay, once we have this, we can construct an atom, right? Okay, so atoms consist of a positively charged protons, a neutral charged or no charge neutron, and the negatively charged electrons. and these electrons are revolving around the nucleus. So the protons and neutrons alone forms the nucleus, right? This much we know. Next, what are the subatomic particles? So we got to know what are atoms, and we construct an atom using these subatomic particles. What are the different subatomic particles, guys? So first subatomic particle is a proton. So what is a proton? Proton, the charge by sign, it is having a positive charge. It is having a positive charge, and the magnitude of charge is 1.609 into 10 power minus 19. Okay, so the magnitude of charge is 1.609 into 10 power minus 19. Okay, cool. Then, so yes, we got a proton, and the charge on it is 1.602 into 10 power minus 19 coulombs. Then its symbol or its SI unit is coulombs. Okay, so it's COULOMBS. It's coulombs. Okay. Next, we have neutron, a neutron whose charge is always neutral. It has no charge, it has zero charge. But observe one thing, the mass of proton is 1.67 into 10 power minus 27 kgs. And mass of neutron is also 1.67 into 10 power minus 27 kg. Next, we have one more. What is that? Yes, almost same. Next, we have an electron. See, the size of electron, though they show this much, actually this is the zoomed or magnified one. Size exaggerated andre ಇದು ಸ್ವಲ್ಪ ಮ್ಯಾಗ್ನಿಫೈ ಮಾಡಿರೋದು. Actual size of electron is much more smaller than what is being shown here. Okay, so electron's mass is very very less. How much? What's the difference? At least 10 power 4. It has a difference of at least 10 power 4. 10 power 4 and resto 10,000 times. See, a proton is at least 10,000 times bigger than an electron anboda, right? Haudu, yes. But observe the charge. The charge on proton. Observe the charge, guys. Observe the charge. The charge on electron and proton. The charge on electron and proton still remains the same. The magnitude of charge, only the magnitude, guys. What is magnitude? What is magnitude? Magnitude andre no? It's the number, not the sign. Magnitude is only the number. Okay, the number or the magnitude of proton, charge on proton and electron is same, 1.602 into 10 power minus 19. But by convention, we consider proton to be positively charged, and by convention, we consider electron to be negatively charged, and neutron doesn't have any charge. Okay, these are the subatomic particles. Why should we know? We should know to say what is positive charge and what is a negative charge. How do we get a positive charge and how do we get a negative charge? Tell me, guys, quickly tell me, how do we get a positive charge? How do we get a negative charge? Say I have my neutral atom here. Again, I come to my atom. So in this atom, I have some positively charged particles called protons, some negatively charged particles called electrons, and neutral charged particles called neutrons. Now, can I make this atom positive charge? Can I make this atom with positive charge? Yes. How? Okay. By removing what? Okay. Can I add positive charges to this? Okay. Here in this case I can, but can I do that in regular cases? No. I can never remove a proton. I can never remove a proton, but I can always remove an electron. Which electron? Which electron can I remove? Can I remove this electron? Can I remove this electron? No, I can't remove this electron because it's not the outermost shell. Which is the outermost shell? This one, the bigger one. Okay, can I remove this electron? Can I remove this electron? Click on yes or no. Yes. Yes, Pampa Kumar, you have any doubts? If you have any doubts, please click on, write your doubts on chat. Yes, okay, you are telling the answer. Yes, yes. Yeah, I can remove this. See, I removed it. Now, see, I still have this electron. Observe this very carefully. I have this electron. Now this atom is neutral. When I remove this electron, observe what happened. The atom got positively charged. Wow. So whenever I remove electrons, whenever an electron or whenever an atom removes or loses electrons, whenever an atom loses electrons, it gains a positive charge. Okay. Now what I do? Okay, I don't want its electron. Okay, and I had one extra electron also. I'll give to this. What happened? The valence shell. I added one extra electron. What happened? See, observe. This atom got itself a negative charge. Why? There was more number of negative charges than positive charges, right? So in an atom, we know the number of positive charges and negative charges are same. Total number of protons is equals to total number of new electrons, right? Yeah. So in an atom, what when can we get a negative charge? So in an atom, if we remove an electron from the valence shell, if we remove an electron from the valence shell, then we get a positively charged ion or positively charged atom. Similarly, when we have a neutral atom, if we add an electron to the neutral atom, say in the valence shell, if I add an electron to the neutral atom, so I'll get a negatively charged atom. Okay, all of you clear till here? All of you are clear here till here, right? Yes. Next thing. So now we come to something called as properties of charge. What are the different properties of charge, guys? Come on. So Ishtartha ki jam. Everyone got this? Yes. Yeah. So we come to something called as properties of charge. What are the different properties of charge, guys? So very first property is, yes, like poles or like charges, sorry, not poles, it's charges. Like charges repel and unlike charges attract. Moksha, you have written wrong. It's always like charges, whatever the like charges, it repels, and unlike charges attract. Okay, it's unlike charges attract, correct? So you can see here I mentioned. So what are the like charges? What are the different possibilities of like charges? Say if I have two negative charges, these two are like charges, so they won't like each other. The like charges don't like each other, so they repel. Okay, if I have two positive charges, they too are like charges, they also repel each other. If I have one positive one and one negative charge, then this attract each other. Yes, cool, cool, guys. So two positive charges repel each other in a charge-free space. Two negative charges in a charge-free region also repel in space. But when a positive and a negative charge is in a space, they attracts each other. This is the first property. So like charges repel and unlike charges attract. Please make a note of this, guys. Everyone, you should write down your notes. So properties of charge, put on the heading properties of charge. So this is the first property, like charges repel and unlike charges attract. Okay, done. Yes, cool. So next property which we go is something called as quantization of charges. It's also called as quantization of charges. What happens here? What happens here? So we saw when we were making atoms. So when we were making atoms, we saw that we always transferred one or two electrons, right? When we were making the atoms. So Nenpidre, now in previous simulation, what we were doing, we were removing an electron or adding an electron. Also I made you see in the simulation, Also we added few positive charges, also the protons also we added them. We also removed some electrons, we also added some electrons, we removed some protons, we added some protons too. But did we ever try this? Did we try to cut an electron and put half of it? Or did we try to cut a proton and put half of it or quarter of it? No. Why not? This is never possible. Okay, this is never possible. So what does quantization of charge mean? So whenever charge transfer takes place, removal or addition of electrons, always a complete charge is removed or a complete charge is added. So if I have a new atom, if I want to say if this is number of protons and number of neutrons, okay, in an atom, so if I have an orbital, I can completely put an extra electron to this or completely remove an electron from this valence shell. But I can never cut this into half. Cut I can never cut this into half and put. So this quantization of charge is given by Q is equals to N into E, where N andre no, N is an integer, right? N is an integer, and E here stands for charge, not electron. E E here stands for charge. Okay. E stands for what? Charge. Okay, so the quantization of charge, maybe it's a positive charge or a negative charge, is always an integral multiple of that charge. Okay, so it's represented by Q is equals to plus or minus Ne. Yes, got it? Not understood. So someone, okay, whoever did not understand, please listen carefully again. So what's happening? Whenever I'm okay, in the simulation I showed you, there was formation of at in formation of atom, I was able to add protons, was able to add electrons, right? So whenever I put an electron or proton, so whenever I'm able to put an proton or electron, what happens in that? Okay, so I was able to put a complete proton or a complete electron, not half proton ugly, half electron ugly. I was not able to put an half electron or a quarter electron. So yes, so what can we say? We are able to put a complete, when we are doing a charge transfer, we are able to put only an integral multiple of the charge. We can put one complete charge or two complete charges, or remove one complete charge, or remove two complete charges, but never half, never quarter. Okay, yes, understand. That is quantization of charge. Next, guys. So yeah, that's what we studied here. Whenever we did the removal of electron or addition of electron, we always did the complete charge. So the third property which comes is charge is conserved. What is conservation of charge says? So charge is always a conserved. What is conservation of charge? So guys, I think most of you have studied conservation of energy by now. Alva, what is conservation of energy? Conservation of energy, I hope all of you remember from your previous class. Okay, yes, no gain or no loss. Okay, fine. Yes, can we say that? Yeah, we can say that. Okay, so energy ke ಏನಿತ್ತು conservation of energy, energy can neither be created nor destroyed, but can be transferred from one form to other form. Similarly, for charges also, charges are always conserved. Say if I have a charge, what does that mean? Say if I have a charge and I keep it in a space, that charge stays forever. That charge stays forever until and unless I put a negative charge. Say consider I have a positive charge, another one positive charge there, I keep it in a space. For how long will that positive charge be there? Until and unless I put a negative charge and neutralize it, that charge which is positive will remain positive. Okay, yes. It can change from neutral to positive or positive to neutral, neutral to negative, or neutral to negative. Yes. It's possible. So example is in an okay. Also, I can say that as in an isolated system, total charge is always same. One more thing is, say, what does that mean? So any object, if you take any object, it consists of a positively charged particle and a negatively charged particle. Agreed? Any object consists of a positively charged particle, also a negatively charged particle. Now, if I have many systems of such positive and negative charges, if I have system of many such things, what can I say? So these charges, the system, the total net charge, the total net charge is always the net charge. Just the say in this case 1 2 3 4 5 6, I have 6 positive charges, and 1 2 3 4 5 6 negative charges. The net charge is to plus 6 minus 6 is always 0. So in an isolated system, the total charge remains always same. The total number of positive charge will be equal to total number of negative charge. Okay. So if you see these objects, say I have a neutral sweater, I have a neutral balloon, and I have a neutral wall. So in all these three cases, what happens? The number of positive charges is equals to the number of negative charges. But can I transfer this? Okay, I can't create a charge, I can't destroy a charge. Okay, the charge is conserved always, right? Now, but can I transfer this charge? Can I transfer, say I have a sweater here, can I transfer the charges in this sweater to something else? Okay, some people say yes, some people say no. Cool. Okay, cool, guys. So what happens? Let's study that in detail. So the other condition is yes, yes, we can transfer the charge. Charges are transferable. So those who don't know, yes, charges are transferable. Okay. Next, I have a question for you. Okay, guys. So I have a question for you. So guys, wait for everyone. So everyone, please read the question first. Don't answer the question in chat box. Don't answer the question. So first thing is we'll read the question, we'll understand the question, then we'll try to answer the question in the polls. Answer only in polls. Rule 2 in NP Jam should always answer only in polls. Okay. So wait, I'll change my ink. Yeah. Okay. So answer only in polls. So I have, which of the following cannot be the value of charge? So what was the value of charge, guys? So if I consider the magnitude of charge, what was it? We studied in the previous slide. What was it? Someone tell me. The magnitude of charges? Yes. In that big box, we saw that, right? Protons, neutrons, electrons. The charges, magnitude of charge. What was magnitude of charge? I told you what was the magnitude of charge. On charge idre adr magnitude is to, yes. Magnitude of charge, this is magnitude of charge. Okay, whenever you have two parallel lines with a central name, so this we call it as magnitude in maths, right? So magnitude of charge q is, okay, 1.6 into 10 power minus 19. That we know, right? Now which of these is not a charge? Okay, you have to think for a moment. Okay, think for a moment and vote your answers in the poll. I think I have launched the poll. So yes, start answering in your poll. Come on, guys. Okay, so there is a common misconception in this. So that's a there is one common misconception in this. So we'll check out that. Okay, so I'm asking which is not a charge, guys. I'm not asking which is a charge. I'm not asking which is not a charge. I'm asking which is not a charge. So I see some students are not yet connected to your audio. Prem Kumar CK, I think I told you how to connect again to Prem Kumar CK. Okay, So others, please put your answers in the chat box. I mean, don't answer in chat box. Answer only in polls. Yeah, put your answers only in polls. First, click on this. Click join audio. So second, click on this. Okay, don't answer Varun. Don't answer in the chat box. Answer only in polls. Don't answer in chat box. Answer only in polls. So everyone, Ashish Shetty, whoever joined now. So connect to your, yes, connect to audio. Join audio, guys. Okay. So if you know these guys, Prem Kumar, Subhash, Ashit Shetty, and others, please ask them to join their audio. Help them to join their audio. Yes, guys. So time's going on. So I see only 46 people out of 97 have answered. Oh my god. Yeah, King. Yeah, King. Magaya King. ಹೇಳಿ ಯಾಕೆ ಆನ್ಸರ್ ಮಾಡ್ತಿಲ್ಲ ಆನ್ಸರ್ ಮಾಡ್ರಪ್ಪ ಯಾಕ್ರಲ್ಲ ಗೊತ್ತಾಗಿಲ್ವಾ ನಿಸರ್ಗ ಅಲ್ಲ ಓಕೆ ಒಂದು ಕಾಮನ್ ಮಿಸ್ಟೇಕ್ ಎಲ್ಲರೂ ಮಾಡ್ತಿದ್ದೀರಾ ಆ ಕಾಮನ್ ಮಿಸ್ಟೇಕ್ ಏನು ಅಂತ ಹೇಳ್ತೀನಿ ಸೊ ಅದಕ್ಕೆ ಮುಂಚೆ ನೀವು ವೋಟ್ ಮಾಡಬೇಕು ನೀವು ಫುಲ್ ಎಲ್ಲರೂ ವೋಟ್ ಮಾಡೋವರೆಗೂ ನಾನು ಕಾಯ್ತಿದ್ದೀನಿ ಸೊ ಐಮ್ ವೇಟಿಂಗ್ ಓಕೆ ಇನ್ನೊಂದು ಗೈಸ್ ಸಪೋಸ್ ಇಫ್ ಯು ಹ್ಯಾವ್ ಸ್ಕಿಪ್ ದ ಪೋಲ್ if you have skipped the poll, there is one option called progress. Poll is on progress ಅಂತ ಅಲ್ಲಿ ಮೇಲ್ಗಡೆ ನಿಮ್ಮ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಪೋಲಿಸ್ ಆನ್ ಪ್ರೋಗ್ರೆಸ್ ಅಂತ ಕಾಣಿಸ್ತಿರುತ್ತೆ ಕ್ಲಿಕ್ ಆನ್ ದಟ್ ಯು ವಿಲ್ ಗೆಟ್ ದ ಪೋಲ್ ಬ್ಯಾಕ್ ಯು ಕ್ಯಾನ್ ವೋಟ್ ಯುವರ್ ಆನ್ಸರ್ಸ್ okay if you have missed the poll or skipped the poll click on poll on progress you'll get back the poll answer the poll and done okay guys so I have waited not so long yes yep I'm going to end the poll so the results guys nodi ಏನಿದೆ most of you have selected D but why okay let's try to answer so guys I told you magnitude of charge is 1.6 into 10 power minus 19 okay so 1.6 into 10 power minus 19 is the magnitude of charge correct right so this is not the answer but this is technically correct then this okay 1.6 into 10 power minus 19 ಆಯ್ತು option C ಬರೋಣ okay say if I multiply 1.6 into 2 that is 3.2 right so this is having 1q is 1.6 into 10 power minus 19 C has 2q so if I take 2q I'll get the option C then C check D say if I take 10q 10 into 1.6 into 10 power minus 19 ಏನಾಗುತ್ತೆ ನೋಡಿ yes correct ಋತುಜಾ so you'll get 1.6 into 10 power minus 18 so this means just 10q okay it has 10 charges but check this how many charges does this have half right this is not possible so this is the correct answer option B is the correct answer guys yes okay charge is quantized the charge on a body q is an integral multiple of charge so q is equals to ne where n is an integer and e is 1.6 into 10 power minus 19 coulomb for 0.8 into 10 power minus 19 coulomb the value of n comes out to be 0.5 which is not an integer and it's not an acceptable value of electric charge so it's not acceptable so this cannot be a charge okay so this is the correct answer got it yes guys come on so next we have something called as modes of charge transfer okay in my previous section I told you we can transfer the charge from one body to another body Okay, in my previous section. Okay, okay, sorry. Yeah, I hope now you are able to see the screen. I had end the stop the results, right? Okay, cool. Yes, yes. Can you see the screen, guys? Please give us if you are able to see the screen. Yes, cool. Okay. So, what is modes of charge transfer? Modes of charge transfer andre enu? So, we said in earlier sections of this slide, this PPT, we said a charge can be transferred from one body to another body. One body ಇಂದ ಇನ್ನೊಂದು ಬಾಡಿಗೆ ಚಾರ್ಜ್ ನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಬಹುದು. Right? Now, how, what are the three modes? Okay, well, there are three modes of charge transfer. Okay, there are how many? Three modes of charge transfer. The first mode is conduction. Okay, the very first mode is conduction. I hope all of you might, okay, most of you might have learned this, some of you might have not learned organo. So first mode is conduction. So what happens in a conduction? When a charged rod, say I have an ebonite rod, so it can be any rod, it can be a glass rod too, glass rod agirbodu, anything which is charged. So this is, I'll call it as a charged body, already charged body alva. So I consider it as a charged body. Now what happens when a charged body comes in contact? So this word in contact, for conduction, a charged body when it comes in contact with an insulated, so this is insulated here, only here. Okay, it's not insulated everywhere, it's with insulated stand. Okay, this is not insulated metal sphere. The insulated metal sphere ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಇದು full insulation ಇದೆಯಾ ಅಲ್ಲ. Insulated metal sphere means it is separated from the ground. Insulated here means separated from ground. ಆಯ್ತಾ, ತಪ್ಪಾಗಿ ತಿಳ್ಕೊಬೇಡಿ, this is separated from ground. Okay, so when a charged ebonite rod, when a charged rod is comes in contact with an insulated, sorry, with a metal sphere, let's consider with a metal sphere, the charge in the rod, whatever the charge the rod has, it moves to the sphere. Okay, the charge on the rod moves to the sphere. This mode of charge transfer is conduction. This mode of charge transfer is conduction. So ಏನಾಗ್ತಿದೆ, so ಇಲ್ಲಿ say consider I have 10 charges. Say I have 10 charges. Now when these 10 charges, when I touch these 10 charges to a metal sphere, what happens? These 10 charges come and accumulate. Okay, next question, guys. So does all 10 charges come and accumulate on metal piece, I mean metal sphere? Okay, does all charge, okay, does all charge come and transfer to this, transfer to this? No, no, ಎಲ್ಲ ಚಾರ್ಜು ಬರಲ್ಲ. No, ಎಷ್ಟು ಬರುತ್ತೆ? Say if this has 10 charges, only 50% of whatever the difference, 50% of difference in potential. Now what is potential, guys? So what is potential? Suppose ನೋಡಿ ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ, I have a glass rod. Consider, guys, I have a glass rod. This glass rod is having some 6 charges. This glass rod is having some 6 charges. Now I have another rod which is having no charge. This is not having any charge. Now if I touch this rod and this rod, what will happen? See, this charge is having a charge of plus 6. I mean, this rod is having a charge of plus 6. This rod does not have any charge. So there is a potential difference of 6 minus 0, that is 6 volts. Okay, ಇದ್ರ ಬಗ್ಗೆ ಮತ್ತೆ ಕಲಿತೀವಿ ನಾವು, will study in detail. So let us consider, this is a very ideal case which I have taken. Okay, suppose I have a higher density of charges here and I have no charges here, then what happens? My charge moves from higher density region, say ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆಯೋ ಚಾರ್ಜು, moves from higher region, higher density region, higher charge region to ಎಲ್ಲಿಗೋಗುತ್ತೆ? lower charge region. Okay, so ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ ನಾವು? This motion, this difference in charge, is also called as potential difference in potential. ಸೊ ಇದು ಸ್ವಲ್ಪ ಜನಕ್ಕೆ ಫಸ್ಟ್ ಟೈಮ್ ಕೇಳ್ತಿರೋ ಅವ್ರಿಗೆ ಅರ್ಥ ಆಗಿರಲ್ಲ, ಬಟ್ ದೋಸ್ ಓಕೆ, ಯಾರ್ಯಾರಿಗೆ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ ಅವ್ರಿಗೆ ಅರ್ಥ ಆಗಿರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ, ಸೊ ಇದರಲ್ಲಿ ಚಾರ್ಜಸ್ ಒಂದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ ಅನ್ಕೊಳ್ಳಿ, ಇನ್ನೊಂದ್ರಲ್ಲಿ ಚಾರ್ಜಸ್ಸೇ ಇಲ್ಲ. ಆ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಇದರಲ್ಲಿ ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಇದೆ, ಇದರಲ್ಲಿ ಚಾರ್ಜ್ ಇಲ್ವೇ ಇಲ್ಲ. ಈ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಏನ್ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತಲ್ವಾ, ಓಕೆ, ಇದನ್ನ ಟಚ್ ಮಾಡಿದಾಗ ಏನ್ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತಲ್ಲ ಅದನ್ನ ಕಂಡಕ್ಷನ್ ಅಂತ ಅಂತೀವಿ. ಸೊ ಕಂಡಕ್ಷನ್ಗೆ ಒಂದು ನೆಸೆಸರಿ ಕಂಡೀಷನ್ ಬಂತು, ಯಾವುದು? ಸೊ ಫಾರ್ ಕಂಡಕ್ಷನ್ ಟು ಅಕರ್, ವಾಟ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್? ಏನ್ ಬೇಕು ಹೇಳಿ? ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್. ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಬೇಕು. Potential difference is a must. Okay, andrenu? Yes, first thing, yeah, very prime most thing is it should come in contact. So yeah, and also it should have some potential difference. Okay, one situation ಕೊಡ್ತೀನಿ ನಿಮಗೆ guys. I'm giving you a situation. Say this ebonite rod is having 10 electrons, right? Say if this ebonite rod is having 10 electrons and this metal sphere also has 10 electrons. Say this metal sphere also has 10 electrons. Now they do touch, both the ebonite rod and the metal sphere touch. Will there be charge transfer? Will there be conduction? Question mark. Will there be conduction? Okay, no. Why? Why not? Why not? Why not? Because ಹೇಳಿ, why not? There is no potential difference, correct alva? ನೋಡಿ, if there is no potential difference, there won't be charge transfer. Okay, so question again. The question is, if ebonite rod has 10 electrons and metal sphere also has 10 electrons, will there be charge transfer? Answer was no, there should be potential difference. Okay. Okay guys, if I take the ulta case, say here in this metal charge I have 20 electrons, say hypothetically I might be having 20 electrons. Now the ebonite rod has only 10 electrons or 10 charges. Now does conduction occur? Yes. From where to where? From metal sphere to rod or rod to sphere? If conduction occurs, from metal sphere to rod or from rod to sphere? Yes, from higher region to lower region alva. So here higher region is 20, lower region is 10, so it goes from sphere to rod in that case. So we discussed three different cases. Okay, these are the few different cases where we get charge transfer. So what are two conditions for conduction? First thing is it should be in contact. Second thing is there should exist some conduction, there should exist some potential difference. Okay, other than this nenitapa. So these two should happen. Other than this, what can we say? So here, yeah, in this case, if I had 6 electrons or 6 charges, no, it should not. Okay, insulated here means, guys, yes, it should be insulated andre separated from ground. Insulated means here separated from ground. It should not touch the ground. Otherwise what happens, whatever the electrons it gives, if it's connected to ground, it will flow to the ground ಗೆ ಹೊಂಟೋಗ್ಬಿಡುತ್ತೆ ಎಲ್ಲ. ಸೊ ಇದ್ರ ಹತ್ರ ಇರಲ್ಲ, ಆಯ್ತಾ? ಅದಕ್ಕೆ ಗ್ರೌಂಡ್ ಟಚ್ ಮಾಡಬಾರ್ದು. ಓಕೆ, okay, cool. So one more thing is, in conduction, whatever the charge it has, the same charge is being transferred. So in conduction, say if it has say in this case, if it has 6 charges, it will transfer 3 charges to this. It will hold 3 charges with that positive charges initially. Finally also it will have positive charges only. So to the charging surface also, if this is a charged body and if I call this as a charging body which is getting charged, so both will have same charges. This is very important, note this. say whatever the charge this conducting rod would be having, the same charge will be transferred to the connecting rod, connecting object, whatever it is. So if so here, if I am transferring negative charge, the same negative charge is being received by the metal sphere. Okay, this is conduction. Next, guys, so we have something called as friction. What is friction? Say in a neutral sweater, if I bring a neutral sweater, if I bring a neutral balloon with to a neutral sweater and rub it. ಸೊ ಒಂದು ನ್ಯೂಟ್ರಲ್ ಸ್ವೆಟರ್ ತಗೊಂಬಂದು ಒಂದು ನ್ಯೂಟ್ರಲ್ ಬಲೂನ್ ತಗೊಂಬಂದು ಎರಡನ್ನು ರಬ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ದ ಚಾರ್ಜಸ್ ಪ್ರೆಸೆಂಟ್, ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ದ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಬಲೂನ್, ಸಾರಿ, ದ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಸ್ವೆಟರ್ ಇಸ್ ಅಕ್ಯುಮುಲೇಟೆಡ್ ಆನ್ ದ ಬಲೂನ್. ಸೊ ಏನಾಗುತ್ತೆ, ಎಲ್ಲ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ನ ಈ ಸ್ವೆಟರಿಂದ ಬಲೂನ್ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಾಗುತ್ತೆ. ದಿಸ್ ಟೈಪ್ ಆಫ್ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಇಸ್ charge transfer by friction. So let's check a simulation if we have. Yes. Okay, so one simulation ಇತ್ತು ನೋಡುವ. Okay, ಇದರಲ್ಲಿ ಎರಡೆರಡು ನೋಡುವ. So what I have here, yes, cool. Actually, so sweater acquires only positive charge. Prasad, sweater acquires only positive charge when it retains only the positive charge. The balloon acquires the negative charge. What happens? So when I bring the balloon and rub on the sweater, see, you can see this. When I bring the balloon and rub on the sweater, so all the negative charges on the sweater is being accumulated by the balloon. Now what happens, there is a net positive charge. There's only a positive charge on the balloon, sorry, positive charge on the sweater, and only negative charge on the balloon. So now if I leave this, see, if I leave the balloon, it will go attract to the sweater. Okay, so this is by nature, by materialistic properties. So the sweater retains only the positive charge and it gives all the negative charges. Like hair, human hair also retains all the positive charge. When I rub my hair, it gives out the negative charges and retains the positive charges. It depends on the material. Okay, again, so there was net positive charges, only positive charges on sweater, only negative charges on balloon. ಇವಾಗ ನೋಡೋಣ ಇನ್ನೊಂದು. Say if I have, instead of one balloon, if I had two balloons, and I'll rub half of the sweater with one balloon and other half with the other balloon. Okay, now no moksha. So I have made this. See, what did you see here, guys? See, now this balloon is also negatively charged, this balloon is also negatively charged. What is happening here? See, these two are repelling each other. Why? We studied that, yes, these two have acquired negative charges. We studied that the like poles repel, the like charges repel. So here I have a balloon, two balloons are having same charges, so these two charges are repelling each other. Okay, now guys, see, if I leave here, it will go. Okay, though it repels from here, okay, though it repels from here, okay, it's, I'll remove the wall. So this repelling from here, but still it will repel the balloon, but it still goes and attracts to the sweater. Okay, now what I'll do, okay, I'll take the balloon, I'll rub it, I'll acquire negative charge. Now this balloon is negatively charged and this sweater is positively charged, so it's attracting, right? Now what happens if I bring this balloon close to a wall? Guys, before we go to the wall, check the total number of positive and negative charges in the wall. Yesterday nodi, total number of positive charges and total number of negative charges in a wall, are they equal? Quantization of sorry, conservation of energy, yeah, conservation of charge, yes, see there. Now what happens if I bring my balloon near the wall? What happens? See, ಏನಾಗ್ತಿದೆ, all the like charges, like the negative charges which are present in balloon is repelling all the negative charges in the wall. Wall aliro ella negative charges na repel ಮಾಡುತ್ತೆ and it creates a net positive charge here. It creates a net positive charge here on the surface of the wall. So what's happening? There's a net positive charge separate ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂತು, ಒಂದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬಂತು, ಇದೆರಡು ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ, ಆಪೋಸಿಟ್ ಚಾರ್ಜಸ್ ಅಟ್ರಾಕ್ಟ್ ಈಚ್ ಅದರ್ ಅಲ್ವಾ, ಹಂಗೆ. Now what can you conclude? So this balloon is forcibly inducing a charge on the wall. This mode of charge transfer is called as induction. Okay, this mode of charge transfer where the total number of positive and negative dipoles, idna dipole anta ಕರಿತೀವಿ ಆಯ್ತಾ. So total number of positive and negative charges present does not change. ನೋಡಿ ಇವಾಗಲೂ after being induced also total number of positive charges and negative charges remain the same, though the wall is still neutral, but yet it has a net positive charge created near the surface where balloon sticks. ಈ ಬಲೂನ್ ಎಲ್ಲಿ ಅಂಟ್ಕೊಳ್ಳುತ್ತೋ ಅಲ್ಲಿ ನೆಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಇದರಿಂದ ವಾಟ್ ಕ್ಯಾನ್ ವಿ ಸೇ, ವಾಟ್ ಕ್ಯಾನ್ ವಿ ಕನ್ಕ್ಲೂಡ್? Yes, see, when I remove the balloon, again it becomes rearranges itself and becomes neutral. When I bring the balloon near it, it repels all the electrons and creates a net positive charge. This is forcibly induced charge. So this is called as the charge transfer by induction. Aita? Huh? Correct? Okay. Yes, initially everything was neutral. So I brought the balloon, I rubbed on the sweater, the balloon got negatively charged, the sweater got positively charged, and when I bring this balloon to the wall, yes, the wall got induced with a charge. Understood? Yes, guys. So let's go back to classroom. Yeah. So next thing was induction. When a charge, okay, I have two examples. One which we studied, when a charged body is brought near a neutral object. When a charged body is brought near a neutral body, there is a formation of opposite charges on the other body. Nodi, for example, here I have an ebonite rod which is negatively charged. When this is brought near a neutral metal sphere, I have a neutral metal sphere. See, the number of positive and negative charges are same. When I brought this negatively charged rod near this, what happened? There was a creation of net positive charges only on one surface. All the negative charges were repelled away. All the negative charges were repelled away. So it created a net positive charges here. This net positive charges created was induced because of this rod. Okay. So this is example for induction. And induction is always attractive. ನಿಮ್ಗೆಲ್ಲೇ ಇಂಡಕ್ಷನ್ ಬಂದ್ರು, wherever you see in attractive, say if they ask in question, so in your J mains they will ask a question like this. So if two rods are after charge transfer they are attracting to each other, then what type of charge transfer did it occur? Yav type of, which type, guys? Which type of charge transfer did it occur? Say if there are two rods and they involved in some mode of charge transfer, and after some time they are attracting, so which type? It is always induction. Okay, if it's attracting, it is induction. Okay, one more. Okay, guys, so next example, which, yeah, you just saw this example, right? When a charged balloon was brought near neutral wall, the charges were repelled, the negative charges were repelled, and net positive charge was formed here, hence attracting the balloons. This is also induction. This is the example for induction. So if you have understood so far, answer this question. So again, guys, rules. First we'll read the question carefully. Once we read the question, I'll launch the poll, you will answer. Okay, the question goes like this. So I'll explain the question also. So a positively charged glass rod. Okay, what I have a positively charged glass rod. This glass rod is positively charged. Okay, a positively charged glass rod is used to charge two neutral conductors using two different methods. So I have two neutral conductors. Where are those? Okay, I'll take one green conductor. So I'll take one green conductor and call it C1, and I'll take one blue conductor. Okay, excuse me. Okay, I'll take one more, a blue conductor, and I call it C2. Okay. Now I'll transfer the charge present in this glass rod. Whatever the glass rod I have, I'll transfer its charge to C1 and C2. Okay. Assume I have transferred. I have transferred some charge to C1. Have transferred some charge to C2. Okay. I don't know which charge I transferred. Now, what is happening? Neutral conductors ಏನಾಗ್ತಿದೆ? Conductor 1 becomes attracted. See, this and this become attracted. So conductor 1 becomes attracted. Now, and conductor 2 is being repelled. So conductor 2 is being repelled. Okay, conductor 2 is repelled. Okay, which methods are used to charge these conductors? So C1 mode of charge transfer yadu, C2 mode of charge transfer yadu? This is the question. So you have four options. Option A says charge by conduction, charge by conduction, charge by induction, charge by induction. Option C says charge by conduction, induction. Option D says charge by induction and charge by conduction. Which among these is right answer? So try to answer this, guys. Have launched the poll. ನೋಡಿ ಯಾವ್ದು ಕರೆಕ್ಟ್ ಇರ್ಬೋದು ಆನ್ಸರ್. ಡೋಂಟ್ ನೋ ಸರ. ಟ್ರೈ ಮಾಡಿರಿ, ನಾನು ಈಗ ತಾನೇ ಹೇಳಿದೆ, ಟ್ರೈ ಮಾಡಿ. ಟ್ರೈ ಮಾಡೋದ್ರಲ್ಲಿ ತಪ್ಪೇನಿದೆ? ಸೊ ಅನಲೈಸ್ ಮಾಡಿ ಏನಾಗುತ್ತೆ. ಸೊ ಐ ಹ್ಯಾವ್ ಅ ಚಾರ್ಜ್ ಗ್ಲಾಸ್ ರಾಡ್. ದಿಸ್ ಚಾರ್ಜ್ ಗ್ಲಾಸ್ ರಾಡ್ ಅಟ್ರಾಕ್ಟ್ಸ್ ಒನ್ ಆಫ್ ದ ಕಂಡಕ್ಟರ್. ನೋಡಿ, ಒಂದು ಚಾರ್ಜ್ ಗ್ಲಾಸ್ ರಾಡ್ ಇದೆ, ಎರಡು ಕಂಡಕ್ಟರ್ ಇದೆ. ಓಕೆ, ಇದೆ. ಸಿ ದಿಸ್ ಗ್ಲಾಸ್ ರಾಡ್ ಇಸ್ ಚಾರ್ಜಿಂಗ್ ಬೋತ್ ಆಫ್ ದಿಸ್. See, note, this glass rod is the one which is charging conductor C1 and conductor C2. ಎರಡು ಕಂಡಕ್ಟರ್ಸ್ನ ಇದೇ ಗ್ಲಾಸ್ ರಾಡ್ ಚಾರ್ಜ್ ಮಾಡ್ತಿರೋದು. ಓಕೆ, ಸೊ ಒಂದು ಕಂಡಕ್ಟರ್ ಜೊತೆ ಅದು ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿದೆ, ಇನ್ನೊಂದು ಕಂಡಕ್ಟರ್ ಜೊತೆ ಅದು ರಿಪಲ್ ಆಗ್ತಿದೆ. ಒಂದು ಕಂಡಕ್ಟರ್ ಜೊತೆ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿದೆ, ಇನ್ನೊಂದು ಕಂಡಕ್ಟರ್ ಜೊತೆ ರಿಪಲ್ ಆಗ್ತಿದೆ. ಯಾವುದು, ಯಾಕೆ? So it's attracting one conductor and it's repelling other conductor. So which type of charge transfer occurred in first and which type of charge transfer occurred in second? This is my question. Okay, Samsung Galaxy, please rename yourself. So guys, I think I sent you the rename codes for your schools. Yeah, most of you have done. Thank you. So yep, yes, so excuse me. Yeah, I see only 41 of 87 students have voted. ಇನ್ನು ಕಾಯ್ಬೇಕಾ? ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಿದ್ಯಾ ಗೈಸ್? ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಿದ್ರೆ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಿದೆ ಅಂತ ಹೇಳಿ, ಅಥವಾ ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ಅಂತ ಹೇಳಿ ಚಾಟ್ ಬಾಕ್ಸಲ್ಲಿ ಹೇಳಿ. ಯಾವುದಕ್ಕೂ ನಾನು ನಿಮ್ಮ ಹೆಸರು ಮಾತ್ರ ತಗೊಳ್ಳಲ್ಲ. ಓಕೆ, ಗೋ ಫಾಸ್ಟರ್. ಓಕೆ, ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಿದ್ಯಾ? ಫಸ್ಟ್ ಟೈಮ್. ಓಕೆ, ಫಸ್ಟ್ ಟೈಮ್ ಕೇಳ್ತಿದ್ರೆ ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ, ಆಯ್ತಾ? Okay, once again, somebody is asking once again. So guys, if you have skipped the poll, click on progress, poll on progress ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿ, ಬರುತ್ತೆ ವಾಪಸ್, ಆಯ್ತಾ? ಪೋಲ್ ಆನ್ ಪ್ರೋಗ್ರೆಸ್ ಅಂತ ಒಂದು ಟ್ಯಾಬ್ ಇರುತ್ತೆ, ಅದ್ರ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ಪೋಲ್ ವಾಪಸ್ ಬರುತ್ತೆ. ಸೊ ಎವ್ರಿಬಡಿ ಕ್ಯಾನ್ ಹೂ ಡಿಡ್ ನಾಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕ್ವಶನ್, ಪ್ಲೀಸ್ ಸ್ಕಿಪ್ ಯುವರ್ ಪೋಲ್. ಯಾರ್ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅವ್ರು ಸ್ಕಿಪ್ ಮಾಡಿ ಪೋಲ್ನ, so that you can see the screen. So what's happening, guys? Okay, ಇನ್ನೊಂದ್ಸತಿ ಕೇಳಿ. I'm explaining the question again. So I have a positively charged glass rod. ಇಲ್ಲಿ red color is my positively charged glass rod. ಕಾಣಿಸ್ತಿದ್ಯಾ? Yes. Okay, so I have a positively charged glass rod, red color one. Now this glass rod has some charge. Okay, so this charge conductor is charging two other conductors. So glass rod ಎರಡು ಕಂಡಕ್ಟರ್ಸ್ನ ಚಾರ್ಜ್ ಮಾಡ್ತಿದೆ. ಓಕೆ, ಸೊ ಎರಡು ಕಂಡಕ್ಟರ್ಸ್ನ ಚಾರ್ಜ್ ಮಾಡಿದ್ದಾಯ್ತು. ಇವಾಗ ಸೊ ಇದಕ್ಕೆ ಸ್ವಲ್ಪ ಚಾರ್ಜ್ ಕೊಡ್ತು, ಕ್ಯೂ 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 ಅಂತ. ಇದಕ್ಕೆ ಸ್ವಲ್ಪ ಚಾರ್ಜ್ ಕೊಟ್ಟರು, ಕ್ಯೂ 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 ಅಂತ. ಓಕೆ, ಇವಾಗ ಏನಾಗ್ತಿದೆ, ಚಾರ್ಜ್ ಕೊಟ್ಟಾದ್ಮೇಲೆ ಇದು ಬರುತ್ತೆ ಆಚೆ. ಚಾರ್ಜ್ ಕೊಟ್ಟಾದ್ಮೇಲೆ ನೋಡುತ್ತೆ, this glass rod and the first conductor is being attracted. ಎರಡು ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿದೆ. ಫಸ್ಟ್ ಗ್ಲಾಸ್ ರಾಡ್ ಮತ್ತೆ ಫಸ್ಟ್ ಕಂಡಕ್ಟರ್ ಎರಡು ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿದೆ. ಸೆಕೆಂಡ್ ನೋಡಿ, ಗ್ಲಾಸ್ ರಾಡ್ ಅಂಡ್ ಸೆಕೆಂಡ್ ಕಂಡಕ್ಟರ್ glass rod, and the second conductor is repelled. ಓಕೆ, ರಿಪೆಲ್ ಅಂದ್ರೆ ಗೊತ್ತಲ್ಲ, ದೂರ ತಳ್ತಿದೆ. ಯಾಕೆ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಯಾಕಾಗುತ್ತೆ ರಿಪಲ್ಷನ್ ಮತ್ತೆ ಅಟ್ರಾಕ್ಷನ್? ಸೊ ಯು ಶುಡ್ ನೋ ದ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಚಾರ್ಜ್, ರೈಟ್? ಫಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ಏನಿತ್ತು? ಇಫ್ ಯು ನೋ ದ ಫಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ಯು ವಿಲ್ ನೋ ದಿಸ್ ಆನ್ಸರ್. ಫಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ಏನಿತ್ತು? ಲೈಕ್ ಪೋಲ್ಸ್, ಸಾರಿ, ಲೈಕ್ ಚಾರ್ಜಸ್ ಏನ್ ಮಾಡುತ್ತೆ? ಲೈಕ್ ಚಾರ್ಜಸ್ ರಿಪೆಲ್, ಕರೆಕ್ಟ್. ಸೊ unlike charges attract. So just now I told you, yeah, so 70 out of 85 students have answered. Okay, I'm going to end the poll here, guys. Okay, so ಸುಮಾರು ಜನಕ್ಕೆ ಅರ್ಥ ಆಗಿದೆ ಅನ್ಕೋತೀನಿ, ಯಾಕಂದ್ರೆ ಮೋಸ್ಟ್ ಆಫ್ ಯು ಹ್ಯಾವ್ ಚೂಸನ್ ಡಿ. Okay, some C and some B. Okay, I'm going to end your okay, stop sharing. So guys, ನೋಡೋಣ ಏನಾಗ್ತಿದೆಯಪ್ಪ. when this both are attracting, when these two are attracting, say the glass rod 1, the glass rod and conductor 1, the red color glass rod and the green color conductor, if they are attracting, what type of force? ನಾನು ಅಟ್ರಾಕ್ಟಿಂಗ್ ಅಂದ್ರೆ ಯಾವುದು ಅಂತ ಹೇಳಿದ್ದೆ? ರಿಪ್ಲೈ ಇನ್ ಚಾಟ್. If you see anywhere, if two conductors are attracting, which is that force, or which is that the mode of charge transfer? I told you just now. Yes. So if two conductors or two things are attracting, it's always because of induction, or induction is always attractive. Induction is always attractive. It can be another nodi. Induction is always attractive, but if it's always attractive, it will not be induction. Induction idre always attractive. Induction idre always attractive. ಆಯ್ತಾ? ಇಂಡಕ್ಷನ್ ಇದ್ರೆ ಆಲ್ವೇಸ್ ಅಟ್ರಾಕ್ಟಿವ್, ಬಟ್ ಆಲ್ವೇಸ್ ಅಟ್ರಾಕ್ಟಿವ್ ನೀಡ್ ನಾಟ್ ಬಿ ಇಂಡಕ್ಷನ್. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡಿ. ನೋಡಿ, ಐ ಆಮ್ ರಿಪೀಟಿಂಗ್ ಅಗೇನ್. ಇಫ್ ಇಟ್ಸ್ ಇಂಡಕ್ಷನ್, ಇಟ್ಸ್ ಆಲ್ವೇಸ್ ಅಟ್ರಾಕ್ಟಿವ್. ಬಟ್ ಇಫ್ ಇಟ್ಸ್ ಅಟ್ರಾಕ್ಟಿವ್, ಇಟ್ ನೀಡ್ ನಾಟ್ ಬಿ ಆಲ್ವೇಸ್ ಇಂಡಕ್ಷನ್. ನೆನ್ಪಿಟ್ಲಿ. ಆದರೆ ಅವಾಗಲೇ ಏನಂದಿದ್ದು? ಇಂಡಕ್ಷನ್ ಇಸ್ ಆಲ್ವೇಸ್ ಅಟ್ರಾಕ್ಟಿವ್, but all attractive need not be induction. But in this particular case, yes, when these two charges are, so it's attractive yavaga? If two rods are attractive and it's induction, yavaga heli? If the same rod is being charged, if this same rod charges this red color rod green color rod na charge ಮಾಡಿ attract ಆಗ್ತಿದ್ರೆ, if the same rod charges the other rod and if it is being attracted, then it's induction. Okay, so here glass rod and C1, conductor 1 is attracting, so there exists induction. So same charge ಯಾವ್ದ್ರಲ್ಲಿ ಬರುತ್ತಪ್ಪ? ಇನ್ನೊಂದು ಕಂಡಕ್ಷನ್ ಅಲ್ಲಿ ಏನಂತಿದೆ? if I have some positively charged metal and if I have a metal sphere, what happens if I touch this? These positive charges will come here, right? These positive charges will come here. This is called as conduction. So same charge ivaga. Now okay, this is conduction, correct sir? Conduction gotaito, induction gotaito. Ivaga if I bring this positively charged rod near this positively charged metal, ಏನಾಗುತ್ತೆ? ರಿಪೆಲ್ ಆಗುತ್ತಲ್ವಾ? yes, it repels. So yes, when the same rod charges and if two rods are attracting, then it's induction. If the same rod charges and if it's repelling, it's conduction. So option D is the correct answer. Those who got it, that's correct. Okay, ಒಂದು ನಿಮಿಷ ರಬ್ ಮಾಡ್ಬಿಡ್ತೀನಿ ಆಯ್ತಾ? ಓದಿ, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದರೆ ಇದೊಂದ್ಸತಿ ಓದಿ. I'll do one thing. It is, yeah. And this was the correct answer. Which was correct? D, option D was the correct answer. Okay, option D is the correct answer. So question please. Question is again Rutuja. Okay, next questions. Okay, next question. We'll discuss next question in next class, guys. It's nearly time up. So we'll discuss more questions. So next we'll discuss about Coulomb's law. So this guy was Charles D Coulomb, who gave you Coulomb's law. So in next class we'll discuss about Coulomb's law. I'll give you a note. I'll give you a book where you can solve your questions. So we'll solve more questions using that book. I'll give you that book today. So in your WhatsApp groups. So from next class onwards, we'll start solving the questions from there. So guys, class ಹೆಂಗಿತ್ತು? So ಸ್ವಲ್ಪ ಮಾತಾಡುವ. If you have any doubts, we'll discuss that. Don't leave the class. We'll discuss something. Okay. Don't leave the class. We'll discuss few things. Stay back. ಸೊ ನಾನು ನಿಮಗೆ ಒಂದು ಪೋಲ್ ಕಳಿಸಿದ್ದೀನಿ. ಆ ಪೋಲ್ನಲ್ಲಿ ನೀವು ವೋಟ್ ಮಾಡಬೇಕಾಯ್ತಾ? ಸೊ ನಿಮಗೆ ಓಕೆ, ನಿಮ್ಮ ಕ್ಲಾಸ್ ಹೆಂಗೆ ಅನಿಸ್ತು, ಟೀಚರ್ ಜೊತೆ ಹೆಂಗೆ ಮಾತಾಡೋಕ್ಕಾಯ್ತು, ಟೀಚರ್ ಹೆಂಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರು, ಅದ್ರ ಬಗ್ಗೆ ಒಂದು ಇದಿದೆ. ಸೊ ನೀವು ಅದರಲ್ಲಿ ನಿಮ್ಗೆ ಹೆಂಗೆ ಅನಿಸುತ್ತೆ ಹಾಗೆ ಹಾನೆಸ್ಟಾಗಿ ಕ್ಲಿಕ್ ಮಾಡಬೇಕಾಯ್ತಾ? ಯಾವ್ದು ಇಷ್ಟ ಆಯಿತು ಅದು. ಆ್ಯಂಡ್ ಎಲ್ಲರೂ ಕಂಪಲ್ಸರಿ ಕೊಡಲೇಬೇಕಿದ್ದು. ಓಕೆ, ನಾಳೆ ಫಿಸಿಕ್ಸ್ ಕ್ಲಾಸ್ ಇಲ್ಲ. ನಾಳೆ ವೆನ್ಸ್ಡೇ ಅಲ್ವಾ? ವೆನ್ಸ್ಡೇ ಫಿಸಿಕ್ಸ್ ಕ್ಲಾಸ್ ಇರಲ್ಲ. ನಿಮಗೆ ಫಿಸಿಕ್ಸ್ ಕ್ಲಾಸು ಮಂಡೇ, ಟ್ಯೂಸ್ಡೇ, ಥರ್ಸ್ಡೇ ಮತ್ತು ಫ್ರೈಡೇ. ಓಕೆ, ಸೊ ಎಸ್. Okay guys, so if anyone has any doubts, please you could ask me. If anyone has any doubts, you can ask me. ಏನೋ ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ಬೋದು. Yeah, if you have any doubt, you can ask me in the chat box or yeah, anywhere it's possible. Okay, cool, super guys. Timetable is in your description. ನಿಮ್ಮ group description ಹೋಗಿ. In your group description you will see a option called schedule. ಅಂತ ಒಂದು ಇದು ಇರುತ್ತೆ. ಆ schedule ಅಲ್ಲಿ ನಿಮ್ಮ ಟೈಮ್ ಟೇಬಲ್ ಇದೆ. Okay, click on that. Notes I'll upload right now. So once I have completed this, I'll upload now. So one more about friction. Sir, will there be test on Sunday? No. ಸದ್ಯಕ್ಕಿನ್ನ ಇರಲ್ಲ. ನಿಮ್ಮ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದ ತಕ್ಷಣ ಇರುತ್ತೆ. Soon after completion of a chapter, you will be having a chapter test. So one more about friction. I didn't get what are you asking? So you want example for friction or question for friction? Please be specific. Okay. Dayananda, no. Number of protons and electrons need to be equal, but ಏನಾಗುತ್ತೆ, ಕೆಲವೊಂದು ಅನ್ಸ್ಟೇಬಲ್ ಇರುತ್ತೆ ಎಲಿಮೆಂಟ್ಸು. ಸೊ ಅನ್ಸ್ಟೇಬಲ್ ಇರುವಾಗ ಅಲ್ಲಿ ಏನೋ ಒಂದು ವ್ಯತ್ಯಾಸ ಇರುತ್ತೆ, ಆ ಕಡೆನೋ ಈ ಕಡೆನೋ ಯಾವುದೋ ಒಂದು. ಸೊ ಕೆಲವೊಂದು ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಎಲಿಮೆಂಟ್ಸ್ ನೋಡಿರ್ಬೋದು ನೀವು ಪ್ರೋಟಾನ್ಸ್ ಆ್ಯಂಡ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಅಲ್ಲಿ. ಸೊ ಏನಾಗುತ್ತೆ, ಕೆಲವೊಂದು ಡಿಸಿಂಟಿಗ್ರೇಟ್ ಆಗುತ್ತೆ ನೋಡಿ. ಫ್ಯೂಷನ್ ಮೆಟೀರಿಯಲ್ ಅಂತ ಬರುತ್ತಲ್ಲ ಅದರಲ್ಲಿ. ಕಂಡಕ್ಷನ್ ಇಸ್ ಓನ್ಲಿ ರಿಪಲ್ಷನ್. ಯಾಕಂದ್ರೆ ಸೇಮ್ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ ಕಂಡಕ್ಷನ್ ಅಲ್ಲಿ. ಅಂಬಿಕಾ, ಸೇಮ್ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗೋದ್ರಿಂದ ಲೈಕ್ ಚಾರ್ಜಸ್ ರಿಪಲ್ ಅಲ್ವಾ, ಅನ್ಲೈಕ್ ಚಾರ್ಜಸ್ ಮಾತ್ರ ಅಟ್ರಾಕ್ಟ್ ಆಗೋದು. ಸೊ ಕಂಡಕ್ಷನ್ ಅಲ್ಲಿ ಸೇಮ್ ಟೈಪ್ ಆಫ್ ಚಾರ್ಜಸ್ ಆರ್ ಬೀಯಿಂಗ್ ಟ್ರಾನ್ಸ್ಫರ್ಡ್. ಓಕೆ ಎಸ್ ಸರ್. ಒಂದು ಬಾಡಿಲಿ ಚಾರ್ಜ್ 7 ಇದ್ರೆ ಇನ್ನೊಂದು ಬಾಡಿಲಿ 2 ಇದ್ರೆ ಟ್ರಾನ್ಸ್ಫರ್ ಬೈ ಕಂಡಕ್ಷನ್ ಆಗತ್ತೆ. ಬಟ್ ಎಷ್ಟು ಆಲ್ವೇಸ್ ಈವನ್ ಚಾರ್ಜ್ ಅದ್ರದ್ದು ಮಾತ್ರ ಆಗುತ್ತೆ. ಆಡ್ ಚಾರ್ಜಸ್ದು ಹಾಫ್ ಆಗಲ್ಲ. ಸೊ ನೆಕ್ಸ್ಟ್ ನಿಯರೆಸ್ಟ್ ಈವನ್ ನಂಬರ್ ಯಾವುದಿದೆ ಅದು ನೋಡ್ಕೊಳ್ಳಿ, ಅಥವಾ ಶಾರ್ಟೆಸ್ಟ್ ಈವನ್ ನಂಬರ್ 6/2 3 ಇರುತ್ತಲ್ವಾ, 3 ಆ ಕಡೆ 3 ಈ ಕಡೆ 3 ಹಂಗಾಗತ್ತೆ. ಸೊ ಗೊತ್ತಿಲ್ಲಪ್ಪ, ಎಕ್ಸಾಮ್ಸ್ ಟೈಮಲ್ಲಿ ಏನಾಗುತ್ತೆ ಐಡಿಯಾ ಇಲ್ಲ, ನಮಗೂ ಐಡಿಯಾ ಇಲ್ಲ ಏನಾಗುತ್ತೆ ಅಂತ. ಹೌದು ವಿನಯ್, ಎಸ್, ಫ್ರಿಕ್ಷನ್ ಅಟ್ರಾಕ್ಟ್ಸ್. need not be, yes, but if the same, again I'm telling the condition, right? ಯಾವ ಕಂಡೀಷನ್ ಅಲ್ಲಿ, if two rods are being charged by same conductor. So ನಂತರ ಒಂದು say if this is my rod and yes, if this is my rod, this rod is charged, okay, and this is my another rod, this charge is uncharged. ಎರಡನ್ನೂ ಟಚ್ ಮಾಡಿದೆ ಅನ್ಕೊಳ್ಳಿ. Okay, when I touch these two charges, I mean the charged one will give the charge to the uncharged one, right? ಅವಾಗ ಇದರಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಇದೋ ಅದ್ರ ಹಾಫ್ ಇದ್ರಲ್ಲಿ ಬರುತ್ತೆ. ಓಕೆ, ಆವಾಗ ಇದನ್ನೆರಡನ್ನೂ ಹತ್ರ ತಗೊಂಬಂದ್ರೆ ರಿಪಲ್ ಆಗುತ್ತೆ. ಯಾಕೆ? ದಿಸ್ ಆರ್ ಲೈಕ್ ಚಾರ್ಜಸ್, ದಿಸ್ ಇಸ್ ಬೈ ಕಂಡಕ್ಷನ್. ಎಸ್, ಹೌದು ನಿಖಿತಾ, ಕರೆಕ್ಟ್. ಎಕ್ಸಾಂಪಲ್ಲು ನಿಮ್ಮ ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡಿಸ್ತಾ ಕೊಡ್ತೀನಿ ನಿಖಿತಾ. How can you change a metal sphere positively without touching it? Experience? ನಿಮ್ಮ ಕ್ವಶನ್ ಅರ್ಥ ಆಗಿಲ್ಲ ರಾಜಮ್ಮ. ನಿಮ್ಮ ಕ್ವಶನ್ ಅರ್ಥ ಆಗಿಲ್ಲ ನನಗೆ. ರಾಜಮ್ಮ ಫ್ರಮ್ ಬೆಳಾರಿ. ಹೇಳಿ. Okay guys, so I think it's time for us. Okay, it's not a time, ಇನ್ನ 8 ನಿಮಿಷ ಇದೆ. ಬೇರೆ ಏನಾದ್ರು ಕೇಳಬೇಕಾ, ಏನಾದ್ರು ಹೇಳಬೇಕಾ? ಇಫ್ ಬೋತ್ ಆರ್ ನ್ಯೂಟ್ರಲ್, ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಲ್ಲ, ಎರಡೂ ನ್ಯೂಟ್ರಲ್ ಅಲ್ವಾ. If there is no charge, from where will we get the transfer of charge? It's not possible, right? Okay. ಮತ್ತೆ any other questions guys? So new questions ಕೇಳಿದ ನಾನು ಕೇಳಲ್ಲ ಕ್ವಶನ್. So examples is all of conduction. ಎಲ್ಲಿ ಇಲ್ಲ, all of friction. Ambika, it was all of friction. So friction once again. Okay, just a moment. So friction ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, in friction, say I have a uncharged balloon. When I rub that uncharged balloon on a neutral sweater, both balloon and sweater both are neutral. Balloon and sweater both are neutral. When I rub that balloon over the neutral sweater, what happens? All the negative charges in the sweater will attract, will be accumulated, ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, will be completely transferred to the balloon. ಈ mode of charge transfer ಯಾವುದು? Friction. Nikita, hope you got that. In case of sweater and balloon also it's friction. Samsung Galaxy. What is grounding? Suppose ನೋಡಿ, ನನ್ನ ಹತ್ರ ಒಂದು ಮೆಟಲ್ ಸ್ಪಿಯರ್ ಇದೆ. ಈ ಮೆಟಲ್ ಸ್ಪಿಯರ್ನ ನಾನು ಅರ್ತ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದೆ ಅನ್ಕೊಳ್ಳಿ, ಅರ್ತ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದೆ. ಸಿ ಅವರ್ ಅರ್ತ್ ಇಸ್ ವೆರಿ ವೆರಿ ಹ್ಯೂಜ್ ಅಲ್ವಾ. ಸೊ ವಾಟ್ ಎವರ್ ಎಷ್ಟೇ ಚಾರ್ಜ್ ಹಾಕಿದ್ರು ನೀವು ಅರ್ತ್ಗೆ, ಅದು ಯಾವತ್ತೂ ಕಂಪ್ಲೀಟ್ ಆಗಲ್ಲ. ಅರ್ತ್ ಒಂಥರ ಹೆಂಗೆ ಅಂದರೆ ಇಟ್ ಅಬ್ಸಾರ್ಬ್ಸ್ ಆಲ್ ದ ಚಾರ್ಜಸ್. ಅರ್ತ್ ಅಬ್ಸಾರ್ಬ್ಸ್ ಆಲ್ ದ ಚಾರ್ಜಸ್ ಆ್ಯಂಡ್ ಅಬ್ಸಾರ್ಬ್ಸ್ ಆಲ್ ಎಲ್ಲ ಥರ ಇದನ್ನು ಅರ್ತ್ ತಗೊಳುತ್ತೆ. ಅರ್ತ್ನ ನೋಡೋದಾದರೆ ದೊಡ್ಡ ಕೆಪಾಸಿಟರ್ ಥರ ಅನ್ಕೋಬೋದು. ಇದರಲ್ಲಿ ಫುಲ್ ಎಲ್ಲ ಎಷ್ಟು ಚಾರ್ಜ್ ಹಾಕಿದ್ರು ಅದು ತುಂಬಲ್ಲ. ಫುಲ್ ಎಂಟೈರ್ ಅರ್ತಿಂದ ಎಷ್ಟೇ ನಾವು ಗ್ರೌಂಡಿಗೆ ಚಾರ್ಜ್ ಹಾಕಿದ್ರು ಗ್ರೌಂಡ್ won't get charged. So it will always stay zero. ಯಾಕಂದರೆ ಸರ್ಫೇಸ್ ಆಫ್ ಅರ್ತ್ ಇಸ್ ವೆರಿ 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 ಹ್ಯೂಜ್ ಕಂಪೇರ್ಡ್ ಟು ದ ಅಮೌಂಟ್ ಆಫ್ ಚಾರ್ಜ್ ವಿಚ್ ವಿ ಗಿವ್. ಅದು ಗ್ರೌಂಡಿಂಗ್. ಅದಕ್ಕೆ ಏನಾಗುತ್ತೆ, ಸೊ ಮನೆಯಲ್ಲ ನೋಡಿರ್ಬೋದು ನೀವು, ಗ್ರೌಂಡಿಂಗ್ ಅಂತ ಮಾಡ್ತಾರೆ. ಸೊ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ಸಪೋಸ್ ನಿಮ್ದು ಯಾವ್ದಾದ್ರು ಫಾಲ್ಟಿ ಎಕ್ವಿಪ್ಮೆಂಟ್ ಇದ್ದು ನಿಮ್ಗೆ ಶಾಕ್ ಹೊಡೆಯೋ ಬದಲು ಏನಾಗುತ್ತೆ, ನಿಮ್ಮ ಬಾಡಿಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಅಲ್ವಾ, ಅರ್ಥಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಇರುತ್ತೆ. ಅಂದರೆ ಏನೋ ಒಂದು ಹೈಲಿ ಕಂಡಕ್ಟಿವ್ ಮೆಟಲ್ ಹಾಕಿರ್ತಾರೆ ಅರ್ತ್ಗೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಎಲ್ಲ ಚಾರ್ಜ್ನು ಅರ್ತ್ ಹೇಳ್ಕೊಳ್ಳುತ್ತೆ, ನಿಮ್ಗೇನು ಆಗಲ್ಲ. ದಟ್ ವಾಸ್ ಗ್ರೌಂಡಿಂಗ್. Goldie electroscope experiment. Okay, that was Rutherford's experiment. ಅದ್ರ ಬಗ್ಗೆ ನಾವು ಕಲಿತೀವಿ. ಓಕೆ, ಬೋತ್ ಆರ್ ನ್ಯೂಟ್ರಲ್ ಅಲ್ವಾ. ಬೈ ರಬ್ಬಿಂಗ್ ಏನಾಗುತ್ತೆ, ಓಕೆ ಆ ಲೆವೆಲ್ ಬೇಕಂದ್ರೆ ನೋಡಿ, ವೆನ್ ವಿ ರಬ್ ಏನಾಗುತ್ತೆ, ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಇಸ್ ಜನರೇಟರ್ ಅಲ್ವಾ. ಸೊ ನೀವು ಕೆಮಿಸ್ಟ್ರಿ ಲೆವೆಲ್ಗೆ ಹೋದರೆ, ನಾನು ಕೆಮಿಸ್ಟ್ರಿ ಲೆವೆಲ್ ಹೇಳ್ತೀನಿ, ಸ್ಯಾಮ್ಸಂಗ್ ಗ್ಯಾಲಕ್ಸಿ. ಸೊ ವೆನ್ ಯು ರಬ್, say your plastic or whatever the wool, it gets enough ionization energy so that the valence electrons in the outermost shell is being removed easily. Okay, so ಅದೆಲ್ಲ ಬಂದು ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ ಅನ್ಕೊಳ್ಳಿ ನಿಮ್ಮ ಬಲೂನ್ಗೆ. ಅಷ್ಟೇ, ಬಂತಲ್ಲ, ಎರಡು ನ್ಯೂಟ್ರಲ್ ಇರುವಾಗ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಯಿತು. ಫ್ರಿಕ್ಷನ್ನಿಂದ. ಫ್ರಿಕ್ಷನ್ ಇರುವಾಗ ಹೀಟ್ ಸಪ್ಲೈ ಆಗುತ್ತಲ್ವ, ಸ್ವಲ್ಪ ಹೀಟ್ ಅಥವಾ ಏನೋ ಒಂದು heat, on very very small amount of heat, and that is enough for your electrons to get attracted, removed from that outermost shell. Samsung Galaxy, I hope answered your question. ಶ್ವೇತಾ ಉದ್ಯಾಲ್, ಅರ್ಥಿಂಗ್ ಇವಾಗ ಬೇಡ ಬಿಡಿ, ಅದು 12th ಅಲ್ಲಿ ಇದೆ. ಸಾರಿ 12th ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಲ್ಲಿ ಬರುತ್ತಲ್ವಾ ಮುಂದೆ. ವಿಲ್ ಸ್ಟಡಿ ಅಬೌಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಇನ್ ಫ್ಯೂಚರ್. ಸ್ಯಾಮ್ಸಂಗ್ ಗ್ಯಾಲಕ್ಸಿ ಒನ್ ನಾಟ್ ಇಸ್ ಓಕೆ. ಆಡ್ ಚಾರ್ಜಸ್ ಇದ್ರೆ ನೋಡಪ್ಪ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ಇಟ್ ಡಿಪೆಂಡ್ಸ್. ಓಕೆ, ಇಫ್ ಬೋತ್ ಹ್ಯಾವ್ ಆಡ್ ಚಾರ್ಜ್ then situations are different. If both have even charge, then even divide ಆಗುತ್ತೆ ಕ್ಲೀನ್ ಆಗಿ. ಆಡ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಒಂದು ಚಾರ್ಜು ಸೋರ್ಸ್ ಅಲ್ಲೇ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಲೀಸ್ಟ್ ಆಡ್ ಚಾರ್ಜ್, ಸೇ ಇಫ್ ಐ ಹ್ಯಾವ್ 5 ಚಾರ್ಜಸ್ ಆನ್ ಎ ಬಾಡಿ, ಓಕೆ, ಐ ಕ್ಯಾನ್ ಟ್ರಾನ್ಸ್ಫರ್ 2.5 ಚಾರ್ಜಸ್. ಸೊ 4 ಚಾರ್ಜಸ್ ಅಂತ ತಗೊಳುತ್ತೆ. It will charges 2 charge. It will transfer 2 charges and it will retain 3 charges. What is charge? Is conserver explain? Okay, charge conservation ಅಂದ್ರೆ ನೋಡಿ, ಓಕೆ, ಏನಂದ್ರೆ ಎನರ್ಜಿ ನೋಡಿ, ಒಂದು ನ್ಯೂಟ್ರಲ್ ಆಬ್ಜೆಕ್ಟ್ ಇಂದ, ಒಂದು ನ್ಯೂಟ್ರಲ್ ಆಬ್ಜೆಕ್ಟ್ ಇದ್ರೆ ಅಥವಾ ಒಂದು ಚಾರ್ಜ್ಡ್ ಆಬ್ಜೆಕ್ಟ್ ಇದ್ರೆ, ಇಟ್ ವಿಲ್ ರಿಮೈನ್ ಟು ಬಿ ನ್ಯೂಟ್ರಲ್ ಆಬ್ಜೆಕ್ಟ್ ಆರ್ ಆನ್ ಚಾರ್ಜ್ ಆಬ್ಜೆಕ್ಟ್ ಅಂಟಿಲ್ ಅಂಡ್ ಅನ್ಲೆಸ್ ವಿ ಆಕ್ಟ್ ಆನ್ ಇಟ್. ಓಕೆ, ಅಷ್ಟೇ ರಾಜಮ್ಮ. ಸ್ಯಾಮ್ಸಂಗ್ ಗ್ಯಾಲಕ್ಸಿ ನೋಡಿ, ಈ ಕೇಸಲ್ಲಿ ಯಾವುದು ನಾವು ನೋಡಿದ್ವಲ್ಲ, ಸೊ ಇಲ್ಲೇನಾಗ್ತಿತ್ತು, ವೆನ್ ವಿ ರಬ್ ಏನಾಗುತ್ತೆ, ಸೇ ಡ್ಯೂ ಟು ಸಮ್ ಫ್ರಿಕ್ಷನ್ ಅನ್ಕೊಳ್ಳಿ, ಡ್ಯೂ ಟು ಫ್ರಿಕ್ಷನ್ ದೇರ್ ಇಸ್ ಸಮ್ ಹೀಟ್ ಜನರೇಟೆಡ್, ಅಂಡ್ ದಿಸ್ ಹೀಟ್ ಜನರೇಟೆಡ್ ಇಸ್ ಇನಫ್ ಫಾರ್ ದ ಸ್ವೆಟರ್ ಟು ಲೂಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ವೆರಿ 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 ಮೈನ್ಯೂಟ್, ಆಯ್ತಾ, ನಿಮ್ಮ ಕೈಗೆ ಗೊತ್ತಾಗಲ್ಲ, ಆದರೆ ಬಲೂನ್ ಗೊತ್ತಾಗುತ್ತೆ. So that electrons, that energy is absorbed by this and that energy is absorbed by the electrons, and the electrons are released and are accumulated on the balloon surface. Okay, okay guys, this was modes of charge transfer, and yeah, we studied so far. So see you guys again on yavaga, Thursday na? Yeah, we'll meet you guys again on Thursday. Till then, see you, bye bye.